photoluminescent exit signs present an alternative to tritium exit signs, primarily due to their non-radioactive nature. Compatibility between the two types is non-existent, mainly because of how each generates light. Tritium signs utilize radioactive decay for continuous light emission, whereas photoluminescent signs depend on absorbing and storing ambient light. Performance-wise, photoluminescent exit signs can supply adequate illumination during power failures, but their brightness and afterglow duration generally fall short compared to tritium signs. Tritium signs offer continuous light for many years. There are several advantages to photoluminescent signs. Firstly, the absence of radioactive materials removes any safety hazards related to radiation exposure and eliminates the costs associated with disposing of radioactive waste. Secondly, they are virtually maintenance-free because they do not rely on external power sources or batteries, resulting in reduced upkeep costs. Thirdly, they are environmentally friendly, as they do not release any harmful substances into the environment. However, there are also disadvantages. Firstly, their illumination can be dimmer, particularly in environments with low ambient light levels. Secondly, their afterglow time is shorter, typically lasting less than 4 hours, in contrast to the 20+ years provided by tritium signs. Thirdly, they need regular exposure to light to maintain their charge and effectiveness. Photoluminescent exit signs have found applications across various industrial and commercial settings. They are often suitable for locations that experience occasional power outages or where continuous, high-intensity lighting is not vital. However, they might not be the ideal choice for areas prone to frequent or prolonged power failures. When considering photoluminescent exit signs, there are several other factors to consider. Firstly, ensure they comply with local building codes and safety regulations. It is vital to verify that the signs meet the required standards for visibility and performance in emergency situations. Secondly, strategically place these signs in areas with sufficient ambient light to maximize their charging capability. Proper placement ensures that the signs are adequately illuminated when needed. Thirdly, implement a regular inspection schedule to ensure that the signs are fully charged and visible, especially in the event of an emergency. In summary, photoluminescent exit signs offer a safer, more environmentally friendly, and low-maintenance alternative to tritium signs. However, it is vital to carefully evaluate their illumination capabilities and afterglow duration to determine whether they meet the specific requirements of the installation environment. Proper placement, regular inspections, and adherence to local building codes are essential to ensuring their effectiveness in emergency situations. To delve deeper into the technical aspects, let's examine the charging and light emission mechanisms of photoluminescent materials. These materials contain pigments that absorb photons from ambient light, exciting electrons to higher energy levels. When the light source is removed, these excited electrons gradually return to the ground state, releasing energy in the form of visible light. The intensity and duration of this afterglow depend on several factors, including the type and concentration of the photoluminescent pigment, the intensity and duration of the charging light, and the ambient temperature. Different photoluminescent pigments offer varying levels of brightness and afterglow duration. Strontium illuminate pigments, for instance, generally provide a brighter and longer-lasting afterglow than zinc sulfide pigments. The choice of pigment depends on the desired performance characteristics and the specific requirements of the application. The intensity and duration of the charging light also play a vital role in the performance of photoluminescent exit signs. The signs should be exposed to a sufficient amount of light for an adequate duration to fully charge the photoluminescent material. Insufficient charging can result in a dimmer and shorter-lasting afterglow. Ambient temperature can also affect the performance of photoluminescent exit signs. Higher temperatures tend to reduce the afterglow duration, while lower temperatures can increase it. Therefore, it is vital to consider the operating temperature range when selecting and installing photoluminescent exit signs. In addition to these technical factors, it is also essential to consider the aesthetic aspects of photoluminescent exit signs. These signs are available in a variety of colors and styles to complement the surrounding decor. The choice of color and style depends on the desired appearance and the specific requirements of the installation environment. When selecting photoluminescent exit signs, it is crucial to consult with a qualified lighting professional to ensure that the signs meet the specific requirements of the application. A lighting professional can assess the ambient light levels, the operating temperature range, and the desired performance characteristics to recommend the most suitable photoluminescent exit signs. To ensure the long-term performance of photoluminescent exit signs, it is essential to implement a regular maintenance program. This program should include periodic inspections to verify that the signs are fully charged and visible, as well as cleaning to remove any dirt or debris that may obstruct the light emission. When cleaning photoluminescent exit signs, it is vital to use a mild, non-abrasive cleaner and a soft cloth. Harsh chemicals or abrasive cleaners can damage the photoluminescent material and reduce its performance. In addition to regular inspections and cleaning, it is also essential to replace photoluminescent exit signs when they reach the end of the service life. The service life of photoluminescent exit signs depends on several factors, including the type of photoluminescent pigment, the operating conditions, and the maintenance program. To summarize, photoluminescent exit signs offer a viable alternative to tritium exit signs, providing a non-radioactive, environmentally friendly, and low-maintenance solution for emergency lighting. However, it is crucial to carefully consider the technical factors, aesthetic aspects, and maintenance requirements to ensure that these signs meet the specific needs of the application. Consulting with a qualified lighting professional and implementing a regular maintenance program are essential to maximizing the performance and longevity of photoluminescent exit signs. Furthermore, let's discuss the code compliance aspects of photoluminescent exit signs. Building codes and safety regulations often specify the minimum illumination levels and afterglow duration for emergency exit signs. These requirements are designed to ensure that occupants can safely evacuate a building during a power outage or other emergency. Photoluminescent exit signs must meet these code requirements to be legally installed in a building. The specific code requirements vary depending on the jurisdiction and the type of building. Therefore, it is vital to consult with local building officials to determine the applicable code requirements. In some jurisdictions, photoluminescent exit signs must be certified by an independent testing laboratory to demonstrate compliance with the code requirements. This certification provides assurance that the signs have been tested and meet the required performance standards. When installing photoluminescent exit signs, it is essential to follow the manufacturer's instructions carefully. The manufacturer's instructions provide guidance on the proper placement, wiring, and maintenance of the signs. Failure to follow the manufacturer's instructions can void the warranty and may result in non-compliance with the code requirements. In addition to code compliance, it is also essential to consider the Americans with Disabilities Act, ADA, requirements for exit signs. The ADA requires that exit signs be accessible to people with disabilities, including those with visual impairments. The ADA specifies the minimum size, contrast, and location requirements for exit signs. These requirements are designed to ensure that people with disabilities can easily locate and identify exit signs in an emergency. Photoluminescent exit signs can be made ADA compliant by using tactile characters and high contrast colors. Tactile characters are raised characters that can be felt by people with visual impairments. High contrast colors provide sufficient contrast between the sign and the background to make the sign easily visible. When selecting photoluminescent exit signs, it is crucial to choose signs that meet both the code requirement and the ADA requirement. This will ensure that the signs are both legally compliant and accessible to all occupants of the building. To further elaborate on the installation considerations, let's delve into the optimal placement strategies for photoluminescent exit signs to maximize their effectiveness. The primary goal is to position the signs in locations where they can readily absorb ambient light during normal operating conditions and provide clear visibility during emergencies. Firstly, consider the proximity to light sources. Ideally, photoluminescent exit signs should be installed in close proximity to fluorescent lights, LED fixtures, or other sources of artificial light. The closer the sign is to the light source, the more efficiently it will charge. However, it is important to avoid direct exposure to intense heat or ultraviolet radiation, as this can degrade the photoluminescent material over time. Secondly, analyze the direction of light. The sign should be positioned so that the photoluminescent surface is directly illuminated by the ambient light. Avoid placing the sign in shadowed areas or behind obstructions that would block the light. Thirdly, assess the viewing distance. The size and brightness of the exit sign should be appropriate for the viewing distance. Larger signs with brighter afterglows are necessary for areas with longer viewing distances. Fourthly, consider the mounting height. The exit sign should be mounted at a height that is easily visible to occupants of the building. The ADA recommends a mounting height of between 80 inches and 96 inches above the finished floor. Fifthly, ensure clear visibility. The exit sign should be free from any obstructions that could block the view. Avoid placing the sign behind furniture, equipment, or other objects that could obscure its visibility. Sixthly, consider the emergency lighting system. Photoluminescent exit signs should be integrated with the building's emergency lighting system. The emergency lighting system should provide sufficient illumination to charge the photoluminescent signs during a power outage. Seventhly, implement a regular inspection program. Periodically inspect the exit signs to ensure that they are properly illuminated, free from obstructions, and in good working condition. Replace any damaged or worn signs promptly. Eighthly, document the installation. Keep a record of the location, installation date, and maintenance history of each exit sign. This information will be useful for future inspections and maintenance activities. Ninthly, provide training. Train building occupants on the location and operation of the exit signs. This training will help ensure that occupants can safely evacuate the building during an emergency. Tenthly, consider the environmental conditions. Photoluminescent exit signs are sensitive to environmental conditions such as temperature, humidity, and exposure to chemicals. Choose signs that are designed to withstand the specific environmental conditions of the installation location. In summary, careful planning and execution are essential for successful photoluminescent exit sign installations. By considering the factors discussed above, you can ensure that the exit signs provide reliable and effective emergency lighting for building occupants. Furthermore, let's discuss the environmental benefits of using photoluminescent exit signs compared to tritium exit signs. Tritium exit signs contain radioactive tritium gas, which poses several environmental concerns. Firstly, tritium is a radioactive isotope of hydrogen that emits low-energy beta radiation. While the radiation emitted by tritium exit signs is generally considered to be safe under normal operating conditions, there is a potential risk of exposure if the signs are damaged or improperly disposed of. Secondly, tritium exit signs have a limited lifespan of approximately 10 to 20 years. After this time, the signs must be disposed of as radioactive waste. The disposal of radioactive waste is a complex and costly process that requires specialized facilities and procedures. Thirdly, tritium exit signs can leak tritium gas into the environment. Tritium gas is colorless, odorless, and tasteless, making it difficult to detect. Exposure to tritium gas can increase the risk of cancer and other health problems. In contrast, photoluminescent exit signs do not contain any radioactive materials. They are made from non-toxic materials that are safe for the environment. Firstly, photoluminescent exit signs do not emit any harmful radiation. They simply absorb and re-emit light. Secondly, photoluminescent exit signs have a long lifespan of up to 25 years or more. After this time, they can be disposed of as ordinary waste. Thirdly, photoluminescent exit signs do not leak any harmful gases into the environment. They are completely sealed and do not release any pollutants. In addition to these environmental benefits, photoluminescent exit signs also offer several economic advantages. Firstly, photoluminescent exit signs have lower upfront costs than tritium exit signs. Secondly, photoluminescent exit signs have lower maintenance costs than tritium exit signs. They do not require any batteries or other power sources. Thirdly, photoluminescent exit signs have lower disposal costs than tritium exit signs. They can be disposed of as ordinary waste, eliminating the need for specialized disposal facilities and procedures. In summary, photoluminescent exit signs offer significant environmental and economic advantages over tritium exit signs. They are a safer, more sustainable, and more cost-effective solution for emergency lighting. To add, let's discuss the various types of photoluminescent materials used in exit signs. The performance characteristics of a photoluminescent exit sign, such as its brightness and afterglow duration, depend heavily on the specific type of photoluminescent material used in its construction. Firstly, zinc sulfide pigments are one of the earliest and most widely used photoluminescent materials. They are relatively inexpensive and provide a decent level of brightness and afterglow. However, the afterglow duration is typically shorter compared to newer materials. Zinc sulfide pigments are often doped with activators such as copper or silver to enhance their photoluminescent properties. Secondly, strontium aluminate pigments represent a significant advancement in photoluminescent technology. They offer significantly brighter and longer-lasting afterglows compared to zinc sulfide pigments. Strontium aluminate pigments are also more resistant to degradation from moisture and UV radiation, making them suitable for a wider range of applications. They are typically doped with rare earth elements such as europium or dysprosium to achieve optimal performance. Thirdly, rare earth aluminate pigments are another type of photoluminescent material that offers excellent performance characteristics. They are known for their exceptional brightness and long afterglow durations. Rare earth aluminate pigments are often used in high-performance exit signs and other safety products where visibility is critical. Fourthly, organic photoluminescent materials, also known as fluorescent dyes or pigments, are a relatively newer class of photoluminescent materials. They offer the advantage of being highly tunable, allowing for the creation of a wide range of colors and brightness levels. However, organic photoluminescent materials are generally less durable and have shorter afterglow durations compared to inorganic materials like strontium aluminate. The selection of the appropriate photoluminescent material depends on the specific requirements of the application, including the desired brightness, afterglow duration, cost, and environmental conditions. Strontium aluminate pigments are often the preferred choice for exit signs due to their superior performance characteristics and durability. However, zinc sulfide pigments may be suitable for less demanding applications where cost is a primary concern. In addition to the type of photoluminescent material, the concentration of the material in the exit sign also affects its performance. Higher concentrations of photoluminescent material generally result in brighter and longer-lasting afterglows. However, there is a practical limit to the concentration that can be used, as excessive amounts of photoluminescent material can reduce the mechanical strength and durability of the sign. The particle size of the photoluminescent material also plays a role in its performance. Smaller particle sizes generally result in more uniform light emission and a smoother surface finish. However, smaller particles can also be more difficult to handle and process. The manufacturing process used to create the photoluminescent exit sign can also affect its performance. Proper dispersion of the photoluminescent material in the binder matrix is essential for achieving uniform light emission. The binder matrix should also be transparent and UV resistant to maximize the amount of light that reaches the photoluminescent material. In conclusion, the selection of the appropriate photoluminescent material, its concentration, particle size, and the manufacturing process all play a crucial role in determining the performance characteristics of a photoluminescent exit sign. Careful consideration of these factors is essential for creating exit signs that provide reliable and effective emergency lighting. Lastly, let's touch upon the topic of retrofitting existing exit signs with photoluminescent technology. In many cases, it is possible to retrofit existing electric exit signs with photoluminescent faces, rather than replacing the entire unit. This can be a cost-effective way to upgrade to a more environmentally friendly and energy-efficient solution. Firstly, determine the compatibility of the existing exit sign with photoluminescent faces. Not all exit signs are suitable for retrofitting. It is important to ensure that the existing sign has a removable faceplate and that the internal dimensions are compatible with the photoluminescent face. Secondly, select the appropriate photoluminescent face for the existing exit sign. Photoluminescent faces are available in a variety of sizes, shapes, and colors to match the existing sign. It is important to choose a face that is the same size and shape as the existing faceplate and that meets all applicable code requirements. Thirdly, remove the existing faceplate from the exit sign. This typically involves unscrewing or unclipping the faceplate from the housing. Fourthly, install the photoluminescent face. Carefully align the photoluminescent face with the housing and secure it in place using screws or clips. Fifthly, test the retrofitted exit sign. After installation, test the exit sign to ensure that it is properly illuminated and that the photoluminescent face is charging correctly. In some cases, it may be necessary to make modifications to the existing exit sign to accommodate the photoluminescent face. For example, it may be necessary to remove or disable the internal lighting components of the exit sign. It is important to consult with a qualified electrician or lighting professional before attempting to retrofit an existing exit sign with photoluminescent technology. They can assess the compatibility of the existing sign, select the appropriate photoluminescent face, and ensure that the installation is performed safely and in compliance with all applicable codes and regulations. Retrofitting existing exit signs with photoluminescent technology can offer several benefits. Firstly, it can reduce energy consumption and save money on electricity bills. Photoluminescent exit signs do not require any electricity to operate, so they can significantly reduce energy consumption compared to traditional electric exit signs. Secondly, it can improve the reliability of emergency lighting. Photoluminescent exit signs do not rely on batteries or other power sources, so they will continue to function even during a power outage. Thirdly, it can reduce maintenance costs. Photoluminescent exit signs require very little maintenance, as there are no bulbs or batteries to replace. Fourthly, it can improve the environmental friendliness of the building. Photoluminescent exit signs do not contain any hazardous materials and do not emit any pollutants. In conclusion, retrofitting existing exit signs with photoluminescent technology can be a cost-effective and environmentally friendly way to improve the safety and efficiency of emergency lighting systems. However, it is important to carefully assess the compatibility of the existing sign and to consult with a qualified professional before attempting any modifications.